Hello, good morning, good afternoon, and good evening to everyone who's tuning in. Hope you're doing well and staying safe. On behalf of BioPetro, Arab Oil and Gas Academy, Arab Guru, SPE Egypt section, I'd like to welcome you all for our last session in the Introduction to GIS and Spatial Data Visualization course. I am Mayar Tarek, a third-year gas and petrochemical engineer student at Alexandria University, and I'll be your moderator for today. Before we start, please, I'd like to remind you to drop your questions in the Q&A section below. Please keep the chat box professional and ethical, and please don't forget to submit your quizzes before the deadline. Now, let us give a warm welcome to Dr. Tarek Kandakji, who will give us a session in the spatial analysis and visualization. Dr. Tarek is emerging academic with PhD in geosciences and demonstrated track record in conducting research in multidisciplinary environments, such as international NGOs and universities. Areas of expertise include environmental science, earth science, ecology, atmosphere, air quality, water quality, geomorphology, hydrology, environmental health, land management, and land conservation. Strengths include geospatial analysis and modeling, GIS, remote sensing, and data analysis. Currently, Doctor Tar is working as a GIS coordinator at the city of Lubbock in Lubbock, Texas. Thank you so much, Dr. Tarek, for coming today, and the mic is yours.
Thank you, Mayar. Thank you so much for the introduction, and thank you, Dr. Ahmed, for organizing this session of seminars. Before I start today's topic, I just want to go back real quickly to one of the questions on yesterday's lecture. I think it was posted by Mr. Talal Ahmed. He was asking what is the projection system that's appropriate and can be used for equator countries and countries near equator. And I think I told him that transverse Mercator may not be suitable, but I was wrong. Transverse Mercator is suitable for countries on the equator and near equator. Like all Mercator projection systems are suitable for that, because the line of tangency on Mercator projection is actually the equator. So the equator and within 15 degrees maybe from the equator and countries near the equator have accurate representation in terms of shape and area and all that stuff. But as you move away from the equator, that's where the major distortion can happen. So I want to apologize for not giving the full answer for that question. But yes, transverse Mercator and Mercator are one of the best projection systems used for countries on equator and countries near the equator. So I hope that clarified the issue, and I apologize again, Mr. Talal Ahmed, and I hope this answers you perfectly. Now, without further ado, let's go with our new lecture today and the last one. I hope you guys enjoyed the sessions with us. This course, today's, we're going to talk about spatial data analysis, visualization, and data sources. I apologize. Yesterday, I couldn't have the time to cover data sources, so I moved it to today's lesson, today's lecture, and hopefully you will enjoy it. So today's topic became spatial analysis and visualization and data sources. It's a very important topic. I hope you will make benefit. It's where we can get deeper. We get our feet deeper in the water of GIS, and we're gonna learn some new stuff here. First, let me talk about data sources. There are many data depositories for GIS purposes. Some of these data are free. Some of it you need to pay money. And of course, Esri, the host of Arcmap and ArcGIS, they have their own data set, and we will see in the demonstration at the end of the lecture how you can download data from while you are opening Arcmap. But you can even have a base map. So you have two types of data through Arcmap. You can either have a base map for your work, and you can download data. In order to download data, you need to have ArcGIS or Esri account. So you need to have ArcGIS online account. It's free, you can create it, and it's very helpful. So I advise you all to go to Esri and register and get ArcGIS online account. But for base map, you don't need any account. You just go there and add the base map layer. But if you need data, spatial data, you need the account. Um, when you work with GIS data, and especially when you move it, transfer it from one place to another, there's a very important concept, and this is the next level of GIS experience, which is called geodatabase. Geodatabase is basically the way of organizing your features and layer in a single database. So let's say you have, for the United States, for example, you have many layers. You have the street layers, you have the roads, you have the land use, you have oil fields, all those, like you have many layers. You can arrange them in a database format in a single folder, not single file, but single folder that contains and arrange these data. And there are rules governing the relationship between the features in that database. So geodatabase is the next step of GIS, and hopefully maybe in the future we can make some lectures about it. But read about it, know how you can apply it in your field, and it will be very helpful. The most common way of finding data, basically simply Googling, searching. I don't like to tell people to Google a lot. I like to have the answers myself. But in data, when you search for data, trust me, internet is your best friend, is your best source. Just go there and Google. Let's say you want a shapefile for population in Egypt. Just go Egypt population shapefile, or United States population shapefile. You will have a lot of information. Now, the irony is, we in the Arab world and the third world countries in general, we do not have a systematic data source. We do not, unfortunately, we do not document our resources. We don't have data. We don't document our work, which is one of the major discrepancies I saw between our world and the United States. When I came to the United States in 2013 for my PhD and master's, I was fascinated by the amount of data available and the amount of data registration and collecting data collection. Data collection is very important for the development of any country. And so the data collection in the United States and in Europe is very much advanced. You can almost certainly find anything you want. You're searching for population, you will find it. Searching for petroleum shape files and data, you will find it. Searching for health data, you will find it. And it's all visualized. The good thing is most of these data are visualized and you can see it and download it. Unfortunately, for our part of the world in the Middle East and C1 region, and Africa in general, like the data collection is not efficient and needs a lot of working. And I'm sure once we have a good amount of data, we can utilize it to analyze data and to analyze these data and identify problems and try to solve it. So when you're searching for the internet, if you're searching for country in the United States, like for data for United States or Europe or Australia, you will find good amount of data. But if you are searching for data in the Middle East and the Africa, let's say, and part of Asia, the data amount you will find is not always you will find what you want. That's why NGOs comes in play, because NGOs provide some data sources for all part of the world, especially the third world countries. They try to build a very extensive database, but this database is not enough sometimes, and the resolution, the quality and the resolution of the data is not good. Of course, not all the time. but you can try and see it. So if you are looking for data in our part of the world, in the Middle East or in the Siwana region, Africa, or some parts of Asia, NGOs might be the best source. NASA provides access to many worldwide data that's coming from its satellite system. So the satellite instrument orbiting the Earth and provide information and data through NASA. You can go there and download these data. Government agencies also provide GIS data, but I don't think this is a very good um, uh, choice in some countries, especially the Siwana region, the Middle East, and part of Asia. Government agencies, they do not have data. For me, when I work for the city of Lubbock, which is a government agency, we have data for all Lubbock, like everything you can think of. And like GIS data, you have it available. You can just go online and download the shapefile for population, for taxes, for school districts, for number of students. Like you have unlimited number of data. You can just go download it. And not only for the city of Lubbock, but for all cities in the United States. Almost every city in the United States has spatial data available for download. So it's not a big problem. Now, very important thing is you need to always cite your data source. Always you need to mention the source of your data for honesty reasons. You cannot just put data and not mention the source of that data set. It's not ethical. So the best ethical approach is to cite your data every time you use it. Here's a list of some sources. You have Diva GIS, it's a very known website. You have US Department of Transportation. They have some interesting data about the United States. Diva GIS, I think you can download for all the world. NASA has its Earth data search system. You can go there and download satellite images from different instruments. The USGS has data for the United States. And there are a bunch of data sources like FAO, ICARDA. You can just go there, take a screenshot of this sources, and you can use it, and it will help you to get some spatial data. Let's start with spatial analysis and visualization. As we said, GIS is not only about showing your data on a map. This is not the main purpose of GIS. As you remember, the first lecture we talked about GIS functions. It contains edit and analyze and manipulating of your data. Now, how you do that? What kind of analysis you can do? You can do many type of analysis. I really hope that we will have time at the end of the lecture today to demonstrate you some of those tools. The first thing in GIS is extract analysis tools, like the extraction, how to extract data. Because when you download data, you download sometimes the data set you have. Let's say it covers a huge region. And if you are downloading data, if you're studying, like, let's say Egypt, Libya, and maybe Tunisia in your study area, this is your study area, and you download a data set for Africa, then, but you don't care about all Africa, you care only about those countries, Egypt, Tunisia, and Libya. Like, this is what you want. So what to do with the rest of the data? Do you keep it? You can keep it, but then the processing will be hard. The processing will take longer time. Also, you will be confused, like why you are dealing with data much more than what you want. So we use the extract analysis to select data that you only want. This is what the whole idea about that. And you can store these data, like if you have data for all Africa and you're studying, as we said, Egypt, Tunisia, and Libya, you just select this data set for those three countries and save it. elsewhere and save it whatever you want. And then your analysis will be on this data set only. So you don't have to worry about the whatever in South Africa or Nigeria or Sudan or all that stuff because you don't want them. So the first type is selection tool. It's where you select features based on a certain criteria, like location or a value. So you make selection based on a query analysis, like a sentence query on Python or any type. We will see how to do it. And or it's going to be select by location. You just, okay, I want, let's say, all the roads that are located in Egypt only. Like let's say you have roads data set for all Africa. You don't want that. So you tell GIS, select me the roads that are located inside Egypt. It will select it automatically for you, and then you can save it, export it, and save it elsewhere. Uh, the other type of extract analysis is the cutout, is the clip. Clip is where you cut out a piece of one feature class using one or more of the features in another feature class. As you see here, this is the clip feature. Sorry, this is the clip tool. So you have an input. Let's say you have road. Let's say you have roads. Or let's say you have Africa, and Africa, this is Africa map, and you want Egypt only. And this is because this layer has many information that you want, like it has a lot of information, but you have it for all Africa and you only need Egypt. Then you have a clip feature, let's say like Egypt. This is the map of Egypt, but it doesn't have the information you need. So what you do is just put it there, put the clip feature over the input, and you will have the output feature only Egypt. So you will shrink down the data set of Africa to be only for Egypt, and this will be saved in a separate place. Like you will not lose the original data. It's just you are clipping and saving to another location. Another tool is the split tool. Create a subset of multiple output features class from a single feature. Like let's say you have a map of Africa, and you want to, let's say you have grid system for a certain like you want to divide this into different maps. Like you want to split Africa into multiple maps. So you create a grid where you have zone 1, zone 2, zone 3, zone 4, 5, and 6. So you put this over this one, and the output feature will be 4 features, each one representing the part of the grid assigned to it. I hope this is clear, but so basically it's, if you have a map of a whole region and you have a grid system for that region, you just put that grid system over the map you want, and the output will be these maps cut. It's like you have a cake, or you have a dough, and then you have a mold, like a model for making shapes in that dough, and you put it in there, and you will have the dough split it into different shapes. It's the same as clip as well, but it creates multiple shapes. Like in the clip, you create only one feature, but when you use the split, you split that shape file into, or feature class, into multiple feature classes, not only a single one. Now we're gonna move to another analysis, the overlay analysis. So we finished the extract analysis, how to extract data. Now overlay analysis. Overlay analysis answers the question of what's on top of what. Like we deals with geography, and the way the word is built, like you have things on top of other things. Like you have a piece of land, like you have let's say continent. On top of that continent, there are countries, borders of countries. On top of those countries, you have cities. On top of those cities, you have people. So it's kind of our word is layered, features on top of other features. So the overlay analysis answer the questions what's on top of what, and the pattern of that locality or of that location. Now, new information is created when overlaying one set of features with another. The the first application of overlay analysis is the erase, where you remove parts of one feature based on another feature. Do you remember the dough example? Like you made a dough and you have the model that you want to take piece. Like when you take a piece like a heart-shaped model, you want to make heart-shaped cookie. You have the dough and you have the heart-shaped model, and you put it there. You take the heart shape. The leftover dough is the erase tool, is the output of the erase tool, like the leftovers. And this is helpful when you want to erase something. Like let's say you have a map of Egypt with the governorates, and you want only the cities that has a certain population, but and you just erase that, and you have a map of the cities with high population. So you have Egypt, and you have cities, another feature for cities with high population. But you want to exclude those from the analysis. Let's say you are looking for, you are targeting cities with low population because you need to increase the infrastructure services to it, like education and health. Like you need to build more hospitals in those regions. So you don't care about the areas with high population, and you have that another feature. Then you overlay this over the input, the whole Egypt, and you extract it. And whatever left will be the low population maps. So, and by the way, the clip and the split also, the clip can be a part of the overlay analysis, but it's more kind of, it could follow also the selection tools. Now, the identity here, the input features or portions that overlap identity features will get the attributes of those identity features. I'll explain it like this way. Here's the input, and you have the identity feature, and here's the output. Now, what happened is, like let's say this feature here, the square or the rectangle, you have information. Let's say about population in a certain city. Now you want to add roads that are inside that high populated city, and you have the road for all the countries. What you do, you just put this over this one, and all the information in this will be shared with this one. Like overlap, the features will get the attribute table will be the attribute of this information where the overlap happens. It will be included in the output data set. So it creates a new output with new information, like new information added to the attribute table. The intersect tool explains itself. It's features or portions of feature which overlap in all layers, and will be written to those features will be written to the output folder. Like you just if you have two countries, let's say sharing some sort of border, and you want to highlight that shared border, then it will be intersect. Like if there's overlap between countries or overlap between two features, if they're overlapping and you only care about the overlap area, this is what you want. So you can get that output only. And this is one of the very important tools as well. Union basically merge two features together. Like if and the attribute will be written in the attribute table, like for all the features. Like if you have, let's say, a map of Egypt, and you have the cities of Egypt and Sudan together, like you merge them together, and the output will be for cities in Egypt and Sudan with all the information on both layers in one shapefile. The update, the attribute and geometry of the input features are updated by the update feature in the output feature class. Thereof, the input feature class and the update feature class field's name must match. Like, let's say here, it's a very good example. Like if you have a country that has a certain border, then they did some new adjustment with the United Nations, and they added a new territory for that region, for that country. So you add that new region to the old map, and then the output will be everything updated inside the old borders. Like the old borders data will be updated according to the new border shapefile, and that's why like both layers has to have exact attribute name table in terms of field name. Like you cannot have any discrepancy or any difference in the information associated with each layer. Like if for first layer, it has population, it has landmass area, it has population density, then the update feature must have the same information, no more, no less, because you are updating. So if you need to update data, instead of going and update one by hand, you just have that feature available, you put it there and update it. The next very important spatial analysis tools is the proximity analysis tools. Uh, Proximity analysis, it's very good to see, to capture some patterns in your locality of the data. Now, one of the very important application is buffer, like creates a buffer polygon around input features to a specific distance. Like let's say, for example, you have oil fields and you want to see how many, like what are, what's found within, what type of land found within, let's say, 10 meters from that oil field. So you create a buffer, and then whatever inside oil field you create data. Or if you say, well, no one can be within 100 meter of this oil field, like you are not allowing any kind of business or any kind of land use within 100 meter of oil field, then you drew that in a buffer and you show it in a map, and that will help identify the exact borders. So you have the input, the output. There's two types of output where the buffers are dissolved in each other. Like if you have for each point, the buffers are dissolved like this here. And sometimes you don't want it. You just want to show the border for each line, even though they are overlapping, for each point, sorry, or each line, even though they are overlapping. So you set the dissolve type to none. But if you want more convenient and you just want to remove the overlap and merge all the buffers together, or all the buffers that are overlapping, then you can see the dissolve type, make it all. And this is how it looks. Now, there are two types of assigning buffer. There's like Euclidean and geodesic. Euclidean buffers measures distance in two-dimensional plane, while geodesic buffers are those that account for the actual shape of the Earth. So when you choose Euclidean distance buffer, then basically you are removing the effect of Earth curvature, the Earth surface curvature, and sometimes the results will not be accurate. But if you account for that curvature of the Earth, because let's say point 1 and point B, maybe the line will be this way. How you move this way because of the Earth curvature. You don't move a straight line. You just don't cut the area through. So you use the geodesic buffers to reach more realistic buffers and more representative buffers. And of course, not always you need that. Sometimes you just need the Euclidean buffer. You don't need to go in much more details. Multiple ring buffers, it's very important when you want to start to assign categories away from certain location. Like for example, the time needed to arrive for for a hospital uh, from different locations. So you have the hospital in the middle, and you say like, okay, all those that live within 100 meters of the hospital will reach the hospital immediately, and we will be able to help them in emergency cases. Now, but people living in 200 miles away from the hospital will have more time to come, and they will be in more risk, and etc. You start keep building a ring of buffers to assign categories for in terms of certain location. Now it could be a polygon or a point or line, and you assign multiple buffers. um, the other type of proximity analysis is Tcn polygons. Tcn polygons are very important analysis tools. Like let's say you have maps, you have points here, and let's assume these points are firefighting stations. Like where the firefighters try to go and put up fires. They need to know, like, and you have neighborhood, you have a city, and you have in that city you have multiple firefighting stations. So you want to know what is like if a fire happened in certain point in the city, which is the closest firefighting station to that location. And you want to do this for the whole city. Like you just want to create a map where if fire occurs in this location, then this, like a fire occurred in a location X, for example, then firefighting station A should respond because it's the closest. How we do that? We do that through a Tcn polygon. So any location within a Tcn polygon is closer to its associated point than to any other point input feature. Let me show you the information here. So we have a map. Let's say that these are firefighting stations or hospitals. Let's say firefighting stations, and in a city. Then here's the output, the Tcn polygon. Tcn polygons tells you, like, if a fire occurs within that polygon, in this polygon, any location inside this polygon, the closest fire fighting station that should respond is going to be this one. Another example, let's say these are hospitals, and you want to assign, so these are hospitals, then, and those are polygons. So any emergency case within this polygon, the closest point to it, the closest hospital is this one. Same for here. If an emergency happened in anywhere inside this polygon, the closest hospital that should be responsible is this hospital here. So this, of course, it uses some sort of mathematical concept. It's very interesting to know, by the way. You can, unfortunately, we don't have enough time to discuss the algorithm behind it, but you can go to Esri website and other sources, and you'll find wonderful information how these tools are built. So I hope the Tcn polygon information example is clear. Now, the next proximity analysis tool is the near. It calculates distance and additional proximity information between the input features and the closest features in another layer or feature class. It's about the near. Tells you what's the nearest point. When more than one near feature has the same shortest distance from an input feature, then one of them is randomly chosen as the nearest feature. Like, for example, you have here many, like point to line, point to point to polygon, or mixed. So let's say you have road line here. You have roads, and you have a point of dust emission. So you want to see, like, what are the dust points that are closer to this highway. Like, you want to know, because when dust emits, it will create low visibility conditions and accidents might happen. So you want to know, like, you have this highway and you want to know what are the dust sources that is closest to this road here, and you want to go and mitigate it somehow. So you use the point to line, and it will calculate the distance between all the points and assign the nearest one for that feature. Now, if you have two features are within the same distance from your target layer, then ArcGIS randomly choose one. You don't have to choose, it's just randomly choose one. Now this is tricky sometimes because you don't want one, you want all, and this tool is not helpful unless you don't care about if you have multiple, you just want the closest one regardless of if it's multiple. Now the same thing here, if you have mixed features, it calculates the input feature multiple points to the near feature here. And the same thing, like you have mixed feature types, many mixed feature types. The near feature is the polygon, while the input feature is the roads here. Like it will help you in many aspects, in many reasons for analysis. There's another one similar to the near. It's called the point distance. Here, the output is not a feature class. Here, the output can be. Here, the output will be in the near feature, in the near toolset. The output will be a new feature class and new information. But the point distance, the output is a table. So the point distance determines the distance from input point features to all points in the near feature within a specified search radius. Let's say you have houses, like a layer for houses in a certain city. Like each house is presented by a point. And then you have police stations in the city. Like let's say you have 10 police stations and you have thousands of houses. Like you have 10 police stations and you have, let's say, 5,000 houses. Then this tool will measure the distance between each house and each police station. Now, you define the distance. Like you tell that I need a distance between two, like you define if you need, let's say, within a certain buffer. Like I want to see all the points that are within 100, or let's say, 100 meter from this police station. What are the houses? Like, and you will record the distance. The importance of this tool, it measures the distance itself. It does not just tells you what are the features, but it's important to say, like, okay, this police station, those points are within 100 meters, and here is the distance. Now, let's say you did not put a search radius. You did not assign a search radius. What will happen? It will measure the distance between each point and each police station. Like it will create a very huge amount of data. So let's say you have 1,000 houses and you have 1,000 police stations in a certain city. Then the output will have 1,000,000 field, because you're assigning each point to a like each police station. You measure the distance between a police station and all the houses, and the next police station and all the houses. But when you define a search radius, when you tell it like, okay, I just want to know the distance between the police station and the houses that are within 100 meter of that police station, then the data will be limited to that search radius. And again, the output is a table which has exact distance. So this is the difference between the near and the other buffer analysis, and the near distance. The point distance is different because it tells you what is the distance in a table format. The join tools, are a very important also type of analysis. ArcGIS allows you to associate records in one table with records in another table through a common field known as a key field. So if you have, let's say, lines, if you have points of house points, like you have house points, and also like, and each house has a unique code. And this data set, it tells you the house location and the price of that house. Now you have another data set for this house, but it still for these house data set, but it does not contain the price information. It contains like the owner information, the neighborhood, everything, but it does not has the price information. So you want to incorporate the two data set together. Then you do join. Join will associate these two tables together using the key field, which is the house ID field, and it will put them in one table. It will create a new shapefile where the attribute tables are joined together. Now, when join two tables, you append the attributes from one onto the other based on field common to both. Now, relating tables defines a relationship between two tables, also based on a common field, but does not append the attributes. Now, the relate, join and relate in GIS, join creates like merge or append the two attributes into a single attribute, while the relate does not create that. You can see the merged table, but it does not create it. It's not there. And instead, you can access the related data when necessary. So you can access it, but it will not create a new table. Now, when you join tables in Arcmap, you established a one-to-one or many-to-one relationship. Like you have, let's say, the houses, information about the houses, information about, let's say, the taxes, the owner, the address, and all this information. And you have another point, another shapefile that has the same houses with the same ID, but it only has the price information. Then this is one-to-one relationship. You merge them together. Now, the other type is if you have many-to-one, like you have the houses layer with all the information, and you have a layer of, let's say, cities, and you want to join to see this house in what city it's located. Like you have the houses in a single country, and you have another layer that has the cities, but also defined there's a unique field shared between them, and you want to see like this house in what city it's located, and you merge them together. Here, the zip code will be the key field, like some sort of information field, the location field, like the zip code maybe, or the, let's say, the city ID. Like sometimes you have data, especially when you download from the government, they want to reduce the text, like the amount of text, and they replace it with codes. So let's say you have the house layers, and each house has a code, a city code, while the other layer has the city code and the name, and you join them together, then you will see each house in what city it's located. This is many-to-one, like many houses will be located in one city. Now, when the layers, when you don't have, when the layers do not join, do not share a common attribute, then you can join them spatially. You can join them by location. And you say, well, I want to show, like, let's say you have street maps and houses, and you want to join by location based on location. Like, let's say for the, not for the roads, but for the houses and the cities, you don't have that city ID field. There's no shared city ID field, but you know the location. Then you do spatial join. You put the overlap the points over each other, and then you tell it spatial join based on location. Like these points, I want to show the information of the city that they are located in. So this is spatial join. You can do that. As I said, spatial join is considered part of the overlay analysis. Now, when to use join and when to use relate. We use join when the data in the tables has one-to-one or many-to-one relationship. Now we use relate when the data in the table has one-to-many or many-to-many. Like if you have the city layer and you want to know the like when you have, yeah, like the city layers, and let's say um, and oil fields in that city or houses in that city. So many to many, like the same city, it will be repeated many times in the input feature or in the join feature, and it's also repeated on the other type. So this many to many, or it could be one to many, like you have one house, or let's say one city that contain more than one house. So this is one to many. Here you can use relate, you cannot use join. Again, feel free to look for other information online. It's very helpful. We cannot cover the main concepts here because we're talking about many tools, but feel free to go in that direction, and we will see some examples here. Now, pattern analysis. Analyzing patterns is type of inferential statistics. They start with the null hypothesis that your features or the values associated with those features exhibit spatial randomness pattern. So pattern analysis, as it says here, it's type of statistics. It has p-values, z-score, and all that stuff to tells you if the spatial pattern in your data set is statistically significant or not. Like the average nearest neighbor, which is part of point pattern analysis, calculates the nearest neighbor index based on the average distance from each feature to its nearest neighbor features. And the average nearest neighbor tools returns 5 values: the observed mean distance, the expected mean distance, the nearest neighbor index, the z-score, and the p-value. So here's an example. You have the points here. So this data is clustered. Then it will tell you, it will do analysis and tells you if this cluster is statistically significant or it's just a random effect. It will do analysis and it will tell you that. Now, if the data are dispersed, even if they're dispersed, like is that dispersion a statistically significant or not? The other type of spatial analysis is the spatial autocorrelation, which is Moran's I. The null hypothesis states that the values of the feature are spatially uncorrelated. There is no spatial autocorrelation between the points. Now, the local Moran's I assign categories. Like if you have, let's say, many cities in a country and you want the population, you have population data, it will tell you if the high population cities are close to each other. Like you will see high, it will create categories of, it will define the cities in that country based on categories: high to high, low to low, low to high, and high to low. Like it will show you that this city has a high relationship. So this city has a high population, and there is a statistically significant pattern that this city of high population will have higher, the cities around it will be also high population. The same with low. Cities with low population are surrounded by cities with low population, or cities with low population are surrounded with high population, or high population cities surrounded by low population cities. And this is all based on statistical significance. So that will help you the pattern. Like you will see, for example, areas that has high criminal values, high criminal rate, cities with high criminal rates, maybe the surrounding cities will have low population because there's a high criminal rate, and etc. So it good to capture patterns. Here, Geoda software is, in my opinion, I use Geoda over ArcGIS. When I do Moran's I use Geoda because it's specified for spatial autocorrelation, and it's free. You can download it for free, and it can give you more and better information than ArcGIS. a very important example and very famous example, John Snow's cholera outbreak mapping in 1854. Here, and the cholera outbreak in London, in one of the cities which is London in 1854. And so people did not know where the cholera is coming from. So John Snow created a map. He assigned put the incidents, the outbreak in points. And then he looked for spatial patterns in that region. And he found pumps, water pumps. And he found that most of the death and cholera infections are within a short distance or clustered around one pump. Then they knew that this pump is the source of trouble, and the water was the source of cholera that's causing the outbreak, and they solved the problem. So this problem before the creation of GIS and spatial analysis and all that stuff. And they did it, and you can see the applications of it. Now we're done. We have 10 minutes to go through some of the analysis. By the way, you can go to Esri website and search for the tools and get more information. Now, here's a map of the United States. It has natural gas storage facilities in points, and you have oil and natural gas fields here. So the first thing I want to show you is the base map. This is where you add the base map here. And then you can add data from GIS online. So here you can say, like, let's say states, for example. It will show you the states. You can add this layer, but the thing is, the data here are not editable. You cannot edit them. So let's see, do some quick analysis here. Like I want, let's see, I want to add a data set with the United States, the states of the United States. It takes some time to load. Let's see, I'm going to add it real quick. US, okay, and I'm going to add. All right, I hope it's going to be there. It's going to take some time. Okay, so let me put it in transparent so you can see what's below it. Display, let's put it to 50%. So now we will see the states assigned to it. So now I want to know, first of all, I want to know what are the natural gas storage that are located in the United States, because as you can see here, the natural gas storage facility, let me turn off the base map for now because we don't need it. It's taking a long time to load, and okay, now we don't need that. Okay, instead we need, well, let me remove it. This happens when the base map contains a lot of information, and sometimes it's very hard to load. It takes a long time to load, and this is what's happening here. So let me remove it real quick. Come on. Okay, it's not responding. Okay, remove. All right. So sometimes it's better to create your own base map. So here's the United States map, and you can see that the points, some of the points are away on the natural gas located in Canada. So what I do, I want to select by location. This is the first tool. Select by location. I want natural gas storage facilities that are located in the United States only. And you can choose many relations, like intersect or within a distance. Like maybe you want not only in the United States, but within, let's say, certain distance of it, or completely within. So let's say intersect now and click apply. Now, you need to know something. The selection tool does not create a new feature. The selection tool is just select from one region. Like it adds to the attribute. Like select from the attribute. Yeah, I think there's something wrong with the projection. That's why projection matters, because now you have different projection systems, so you cannot use that. But yeah, on non-simple geometry. Okay, then let us turn off this one and find the selection, select by location. I want the natural gas that are located within an oil field and intersect with it. Okay, there it is. Here's the work. So this tool selected natural gas storage facilities that are inside the borders of an oil field. See these points here? And this is the selections. Like you have 443 out 486. Now let's say you want the points that are outside. Then what you do is just convert to switch selection. And now all the points, you have 43 points out of 486. Let's say you want let's say we have the United States layer and you want clip. You want the oil fields that are only inside the United States and you want them as a separate shapefile. Then you click clip. The input feature here tells you extract input features that overlay the clip feature. Use this tool to cut out a piece of one feature class using one or more feature. So I want to cut a piece of the oil natural gas fields, and the clip feature I want it to be the United States borders. Let's see if it's going to work. The US admins Albert, and here's the output. You can put the output in whatever you want. Let's put our output in our file here. Not the download, sorry. It's going to be in the D folder. It's going to be on GIS and practice, and it's going to be okay. Let's put it here somewhere. Lecture 3. Let's put it in lecture 3 for now. And oil G fields, say for example. Now click save and click option. Now the tool is running. Sometimes it takes some time based on the size of the data, but usually it should be quick. Not always takes time, but if the data has high amount of information, it might take something. You can chase, or you can trace the performance by go to processing results. Current session is running now. It should be the clip. You can see if it's running or not. So it's still running. So the clip feature is still running. And when it's done, it's going to show up here as a new feature. It's going to be a new oil natural gas fields, but based on extracted or clipped from the whole thing. Now, this is useful when you have raster data, like you have, let's say, image of the whole world, like a satellite image of the whole world, and you want only the image of your country, and you have the border of your country as a shapefile. You put it over the raster layer, which is the whole world map, and then you can clip it, and the output will be a raster for your country only. Because as we said before, raster data are very big in size. So loading them will take a huge amount of time. If you are only working on your country, then every time you load that map, it's going to take longer time. So what you do is just clip. You just take that area and focus on it. Now here's the output. Let me close this. Here's the output. And now it showed me only the oil and the natural oil field and natural gas fields in the United States, which is this layer here. See? Now let's turn off this one. And now what we have is our layer that we care about. I wanted to do more demonstrations, but unfortunately we don't have enough time to cover all the tools. But this, I'm going to show you one last thing while you look at this. So this is the oil fields only in the United States. I'm going to show you one last map of I created before, which is for the point pattern analysis. Let me see. Okay, not the Egypt. Let's go to map production 3. And I'm going to show you some point pattern analysis results, which is the annual center point of dust. Okay. So if you look at this, center of dust points. Okay. Let me activate this layer. All right. And let me zoom to dust point here. Zoom. Okay, it's all right. Okay, here it is. So we have a map of these are dust point sources. Arcmap is acting very slow today, very strange. It happens sometimes, but so let me turn off the drought. I don't need that. I just need the point. So these are dust point sources of the United States. Like these points are the source of dust. Now you have all these points, and you can visually see that those points are clustered. But is this cluster of data, is it statistically significant or not? So what we do average nearest neighbor, average nearest neighbor analysis to see if these points are clustered. We go to dust point sources. Where it is, it should be here somewhere. Okay, there it is, dust point sources. And the distance method, you can use Euclidean distance, which is straight line, or Manhattan distance, the distance between 2 points measured along axis at right angles, calculated by summing the difference between x and y. No, I just want the Euclidean distance. And let's generate report and click OK. Now the process is running. The average nearest neighbor. Okay, I think it's done. Let's go to processing and results. Current session, average, still running the average nearest neighbor. So it tells you if this is a random pattern or it's clustered. Visually, you can see it's clustered, but you don't know for sure. So you open the table, you go to the results, and you go to the messages. You go to the report, and here is, let me see. Generate reports. Okay, let me see. The report should be somewhere here. Sometimes it doesn't save it. So add to display. I don't know if it's going to be seen. Let me see where it's located. Okay, let me copy location and open it somewhere and see where it's at. Okay. All right, so here it is. So here's the analysis. So the analysis says that the nearest neighbor score ratio is 0.45, and the pattern is cluster. So this is at the statistically significant cluster pattern. That means the data are clustered, and it's not by random, that there is something causing those points to be close to each other. The p-value is the observed mean distance, such and such. The z-score is -40. The p-value is very low, and the nearest neighbor ratio is 0.45. When you do this analysis, when you do the average nearest neighbor, and let's say you have oil field data and you want to see if they're clustered and you want to report your results, you either report this graph here, or if you don't want to report any images, you just want to say, you can say that oil fields are clustered based on an average nearest neighbor analysis on ArcGIS, where the nearest neighbor ratio is 0.4, and the data are significantly clustered with nearest neighbor ratio 0.4 and p-value less than 0.005. So this is what it tells you. Now, the z-score, I don't want to go through the concepts of statistics, but here's the distribution. So if the data, if the z-score is located here in this region, then your data will be random. And if it's located in this region here, that means your data are dispersed away from each other for something causing these data to be away from each other. Now, we are 6 minutes over the time, and I deeply apologize for that. These are the main tools in the analysis. And let's go if you guys have any questions. I kept you long for,
Thank you.
for a long time.
Thank you so much, Doctor.
All right.
It was super terrific.
I hope so, and I hope I was not boring.
It was so interesting, by the way.
That's good.
I think we don't have any questions. I think I see that it was so clear.
Well, I hope it was not boring. People are asleep now.
No, we have so much attendees. Thank you so much for your effort again.
I think we have some questions, Mayar.
Now we have 2 questions. Are the attributes of one entity influenced by changes in another entity?
Okay. Entity. The attributes of one entity influenced by change in another entity. Are you talking about a specific tool or in general, Talal? He can type that for us.
Someone is asking, can we have the PowerPoint?
Please?
We have this question from lecture 1, by the way.
Yeah. Talking in general, the attribute of one entity influenced by changes in other entity. I don't think I quite get your question. So I will assume that you want to know if the information here, the attributes, this is if you're what you want, because this is the attribute of influence by change in another entity. It depends. Not all the time. It depends on if those data are related. Like if there's a relation, like if you changed one, let's say we went to this point and we changed the information, the change will only be for that entity. It will not be associated with others, because ArcGIS, the way the data are stored here, like let's say the dust point source is here. I changed the land cover for this point here. Like let's say I changed the land cover for this point. If I change it here, it will not be changed for anything else. It will be only for that point. I hope, is this answering the question? Is this the answer you wanted?
We don't have, Dr. Tarek, we don't have any questions now.
Awesome. One
Uh,
more thing I want to mention, Mayar, just before we close.
okay.
There is a tool we call the average center point. Like if you have all these points, and you want the average center, like the point that where you just average all x's and all the y's, and you can have this mean. See this point here? I'm showing. I hope it's showing. This point here is the average location of all the points. This is one of the tools you can use to see like, let's say if you don't want to show the whole data, you just care about like, okay, this incident is happening on average on this location and the surrounding location. So you use the geographic mean center. And thank you. And I was happy to give you guys information, and I hope you
So
benefited from it. And thank you, Mayar, for your wonderful
thank you so much,
clarification.
Dr. Tarek, again. Now, to highlight, this session has been recorded and will be uploaded soon on PyPetro and Arab Guru YouTube channels. So kindly make sure to subscribe on our both channels, and please keep updated because Dr. Ahmed will post the final exams dates on PyPetro. Wish you a great day. Stay safe and bye.
Bye. Thank you.
Bye.